March 13th, 1974. The largest stainless steel nuclear reactor vessel ever made begins the first steps of a 7,000-mile journey. It is bound for the fast flux test facility in Hanford, Washington. It will perform the vital testing necessary to make the next generation of power-producing reactors, called breeders, a commercial reality. We're in Chattanooga, Tennessee. 890 tons of nuclear components make up the entire shipment. The reactor vessel alone, the largest of these components, weighs 700,000 pounds. The trip is to be made by water, 7,072 miles in a period of 34 days. To protect the pieces against the threat of contamination from air and dirt, they've been sealed with a tough plastic cover. During the entire trip, the components will be under a pressure envelope of dry gas, ensuring that no salt air touches them. The first leg of the journey will follow the Tennessee River, winding through Tennessee, Alabama, and north again to Paducah, Kentucky. The shipment will move down the Ohio River to Cairo, Illinois, entering the lower Mississippi River. It will sail 860 miles down the Mississippi to the ocean port city of New Orleans. Moving out the South Pass of the Delta into the Gulf, the ship will cross the Yucatan Channel and the Western Caribbean to the Panama Canal. Passing through the canal, the Voyage will move up along the coast of Central America, tracking the western boundary of the United States. The shipment will arrive at Longview, Washington, to be transloaded onto 2 river barges for the last run inland to Hanford in south central Washington. 1,809 miles by river and 5,219 miles by sea. Fabrication of the major components has taken 4 years, beginning in June 1970. From a sea of boring mills, steel presses, welding machines, and stress relief furnaces, the components have emerged. The nuclear core will be contained in this 350-ton nuclear vessel, 43 feet long. More than 55,000 pounds of welding rod were used to fabricate it. Special welding techniques have pushed the art of stainless steel technology at every step. Its wall thickness, some 2 3/4 inches of steel. Its inside diameter, some 20 feet. The main support structure, made from 2 large steel ring forgings, one the largest ever produced in one piece, the other the heaviest produced in one piece. The closure head, formed from 2 semicircular forgings 22 inches thick, weighs 214 tons. When joined together, the halves form a 25-foot diameter disc, the largest steel forging in history. 4 years of around-the-clock schedules are finally coming to an end. A series of final checks are made. All plates and forgings are painstakingly cleaned and inspected. Fabrication of this mammoth vessel is only one more step in the large-scale breeder reactor program. Its performance in the Washington desert is a vital key in this country's ability to meet future electrical power demands. The project involves a number of national laboratories, numerous engineering centers, and many industrial contractors. More than 20,000 people are actively engaged in the breeder program. Building a new large-scale energy technology like the breeder is a difficult challenge. We've been at it more than 25 years, investing a vast amount of talent and millions of dollars in research and development. The breeder is an advanced nuclear plant that produces electricity, while it actually makes more nuclear fuel than it consumes. Now, that may seem to defy logic, but it's a fact. It makes new fuel by converting the most abundant form of uranium, which is not directly usable as fuel, to a new substance, plutonium, which is. Of all new energy concepts, the breeder is the essential next step to supply the vast amounts of energy needed for the future, the only one that will produce it soon, stretching our energy resources from decades to centuries. Any realistic solution to energy supply has to include the breeder. The key is implementation. The FFTF, 2 years away from completion, is the current focus of the entire breeder program. We are learning a great deal in the engineering of the FFTF, invaluable in the development of future reactors. The energy future of this country may well be shaped by our ability to build and operate breeder reactors. And our breeder program will definitely be shaped by our ability to construct and operate this test reactor, the FFTF. With her multi-million-dollar nuclear cargo secure on board, the Panamanian Inagua Sound embarks on her journey from a former trading post called Ross's Landing. The Moccasin Bend of the Tennessee River in Hamilton County, Tennessee. It's been more than 100 years since the Civil War battle above the clouds at Lookout Mountain. Chattanooga, known historically for her textiles, chemicals, and wood products, will also be remembered for nuclear reactors. The Tennessee River, 5th largest in America, formed by the merging of the Holston and French Broad Rivers of eastern Tennessee. It was discovered in 1514 by the Spanish explorer Hernando de Soto. French and English fur trappers explored this country in the 17th century. Flowing some 562 miles through the great Appalachian Valley, it drains 41,000 square miles, the very backbone of the 40-year-old Tennessee Valley Authority. The Tennessee River cuts a meandering course through folded mountains and green valleys dotted with dogwood. It passes the Clinch River tributary, where the next step in breeder technology will occur, the first large demonstration breeder that will produce electricity in the 1980s.
And Inaugural sound of Nickajack Lock 13.
I get call account, baby, 622.
Inaugural sound of Nickajack Lock 13, 267 feet long, 51 feet wide, a draft of 10 foot 5, over.
Hey, let me find something right on that clip.
During her journey, the Inagua Sound will pass through several TVA locks and dams. Before reaching her destination, the ship will pass through 11 states and 1 republic. The Inagua Sound is a heavy lift ship built for the West India Lines in Orange, Texas in 1969. A crew of 17 are aboard. Her average speed is 12 knots, enabling her to log some 260 miles each day.
Inaugural sound back to Nickajack. Thank you, and inaugural sound clear.
Thank you, Captain, W622. Okay, then, I'll get
The nuclear shipment has traveled the Ohio River for only 45 miles to Cairo, Illinois. Here she is carried into the lower Mississippi, 150 miles south of St. Louis. The journey cruises south for some 800 miles through the alluvial Yazoo Basin. After 5 days, the ship enters the Bayou Levee country of southern Louisiana. In the dark morning hours of March 19th, with only her running light showing, the Inagua Sound silently glides into New Orleans on the east bank of the Mississippi. She's traveled 1,371 miles in 7 days. She'll pause here till daybreak before taking on new supplies. New Orleans, largest city in Louisiana, founded by French and Spanish settlers in 1718. It's been the cradle of jazz music since the turn of the century, fabled birthplace of the term Dixie, gateway to Middle America. Each year, hundreds of thousands of tourists come to the city that care forgot, partaking of the blend of French and Spanish cuisine and exciting nightlife. The romance of 250 years reflected in the unique character of the oldest and most famous section of the city, the French Quarter. Although Mardi Gras comes but once a year, the city's streets are crowded every night with the festive spirit of carnival time. The Port of New Orleans, second only to New York in handling foreign cargo. 4,000 vessels from 47 different countries enter the port annually, a new ship docking every 90 minutes. Where the intercoastal waterway meets the Mississippi, the Inagua Sound readies for her impending 5,200-mile ocean voyage. A port tender loads on new supplies of fuel, food, and water. Following 19 hours in New Orleans, the Panamanian vessel leaves anchorage. The run to the open water of the Gulf of Mexico will be 95 miles through the South Pass. Under heavy leaden skies of rain, she embarks on her journey to Central America. For the next 5 days, she'll navigate some 1,400 miles across the Gulf. Her scheduled arrival time in Limon Bay, Panama, March 25th. The Republic of Panama, 9 degrees north of the equator. The Canal Zone is a 10-mile wide neck of tropical jungle separating two oceans. The canal itself is a 50-mile long lake and lock waterway owned and operated by the United States since 1914. In moving from the Atlantic to the Pacific Ocean, ships do not cross the isthmus from east to west, but from northwest to southeast, eliminating 7,000 nautical miles round Cape Horn. From the harbor city of Cristobal on the Caribbean, the Inagua Sound moves some 7 miles up through the dredged channel leading to the Atlantic Ocean entrance to the canal. Gatun locks, 3 pairs of large concrete chambers. The Inagua Sound will be lifted some 85 feet in 3 separate steps from the tide level of the Atlantic Ocean into Gatun Lake, a man-made reservoir that is the highest point on the canal. The Panamanian vessel is tethered by fender cables to small electric locomotives called mules, which run along either side of the locks. These engines power the ship through the 3 steps of elevation. A canal pilot is in complete charge of the vessel during its entire transit. The steel-locked gates are floatable, weighing between 400 and 700 tons. More than 52,000 gallons of fresh water are used to raise each ship, all of it drawn from the lake. The lockage interval here at Gatun is some 80 minutes. The 61-year-old waterway was indeed an unprecedented engineering feat, costing the United States $387 million. More than 500,000 ships have passed through the canal since its official opening back in 1914. Once again, under her own full power, the Inagua Sound enters the quiet waters of Gatun Lake. $15,000 ships use the Panama Canal every year. Average tolls are $7,000. The cheapest toll ever paid was 36 cents by American adventurer Richard Halliburton when he swam the canal in 1928. Today, the Inagua Sound is one of 40 ships passing through the canal. Her toll, some $1,250. She will navigate Gatun Lake for a distance of 24 miles. When the Inagua Sound reaches the southeastern end of Gatun Lake, she will enter the artificial extension of the lake, the 500-foot wide Gaillard Cut. This channel was truly the most difficult challenge in building the Panama Canal. 230 million cubic yards of earth were excavated to create the 8-mile gorge through the solid rock of the Continental Divide. At sundown, the shipment begins her descent into the Pacific Ocean at Pedro Miguel. The Inagua Sound will be lowered 31 feet in one step. bringing her into Miraflores Lake. After navigating the lake for a mile farther south, the ship ghostly enters the Miraflores locks in complete darkness. Here the Inagua Sound will be lowered another 54 feet in 2 steps, bringing her to the tide level of the Pacific Ocean. Once through the locks, the ship will sail 4 more miles to the Pacific harbor of Balboa. She'll be 27 miles farther east than when she entered the canal. From deep water to deep water, 50 miles. The Pacific Ocean. The Inagua Sound is ending a 3,800-mile voyage to the entrance of the Columbia River. It's been 15 days since she left Panama, 28 days since Chattanooga. The ship is now about 340 miles from Hanford, entering the headwaters of the lower Columbia River, 100 miles west of Portland. It was about here that the legendary Lewis and Clark expedition looked upon the Pacific Ocean in November 1805. Port of entry, Longview, Washington, a lumber manufacturing center founded in 1922. Normal river traffic here is aluminum and wood products. Today, it's also nuclear reactor pressure vessels. For 3 days, the Inagua Sound surrenders her nuclear cargo to 2 large river barges. As the first barge heads upriver, complete transloading continues on the second barge at Longview. The Columbia River, discovered and named by Robert Gray in 1792. The Columbia's power has found its way some 1,200 miles to the sea, cutting the great canyon gorges through the Cascades and coastal Rockies. 30 miles south of Portland, the 11,000-foot summit of Mount Hood majestically towers over the Willamette Valley. The river drains more than 260,000 square miles of orchards, wheat fields, and sheep ranges. On their journey, the barges will pass the mouth of the Yakima River, eventually entering the lava basin of the Columbia Plateau. The discharge point, the port of Benton, a barge slip 8 miles southeast of the reactor site. Monday morning, April 15th. 7,000 miles of shipment by sea and river finally ends. The last miles will be overland. The huge reactor pressure vessel requires a tractor transport crawler to accomplish the last few miles. The overland journey will take 2 more days, moving slower than 2 miles an hour. This vessel is an integral part of an energy technology that will help remove us from the gnawing reality of dwindling fossil fuels, limited uranium resources, and the dependence upon others for our supplies of energy. Man is the dwarf of himself, Emerson once wrote. He is no more that dwarf than in his role of nudging his mammoth energy machine across the open desert. Saturday morning, April 20th. The vessel arrives at the FFTF construction site. 39 days since its departure from Chattanooga. One day, breeder technology will place American hands firmly upon a new source of energy. Energy that can help light our cities for centuries to come.